All right, Mr. Davis just took you through all the observational type studies. That cohort sequential, that last one is, I've never seen it on the test, but it's one of my favorites. So we just put it in here because I think it's a fun one to talk about. Love the longitudinal study, all that other stuff. We will review that, but I want you to go back and look at that. Okay. Now we're going to look at another type. We're going to spend probably the whole time on this one, the whole time on this video, and that is correlational studies. You've heard that there's a correlation between two things. And I'm sure you've heard about it in your other classes, your science classes, they've talked about it. But I want to be very, very careful of what we talk about when we say correlational studies. So in other words, if we know one number, do we know another number? In other words, if we know your math grade, will we also know your science grade? And I would imagine that probably people who have high math grades probably have high science grades, and people who have low math grades probably have low science grades on average. It's probably rare for somebody to get an A in science and an F in math. Who knows? But that's what we're trying to figure out when we're doing a correlation. So we're trying to figure out, do these two numbers travel together? And the most important thing to understand is your math grade doesn't cause your science grade, and your science grade doesn't cause your math grade. I'm going to say this a lot, and Mr. Davis is going to say it a lot too. Correlation does not mean causation. Now, people understand that, but they don't really get it fully. So we're going to talk about that this hour too. So it's measuring whether factors vary together. It does not prove cause and effect. In other words, if I know your height, do I know how good you are at basketball? Maybe. Does that prove that height means you're good at basketball? No. I've known some tall people who could barely walk. So we'll talk about that coming up. So here's a way to think about it. Is there a correlation? In other words, if we know your depression level, can we also, to some degree, predict your self-esteem level? I would think maybe. So does depression cause low self-esteem? Because there's a correlation. If you have high depression, you'll probably have low self-esteem and vice versa. And then if your depression goes down, your self-esteem will probably go up. So does depression cause low self-esteem? And you think, well, yeah, it makes sense that it does. Hold on a second. Don't ever say cause when it comes to correlation, because low self-esteem could cause depression. I don't like myself very much, so I'm depressed. I'm depressed, so I don't like myself very much. Also, it could be there's something going on in my life that's causing both of them. Let me move this over. That's causing both of them. So it could be poverty is causing low self-esteem and depression. It could be another mental problem that's causing low self-esteem or depression. So the only thing we're talking about with correlation is we know that low self-esteem and depression are linked, but we don't know why. So whenever we hear that two things are correlated, all we know is those numbers predictably travel together, and that's all. One thing does not cause another. Okay, and I'm going to say that again and again and again. Here's something that my daughter found very recently. I think it was this year, actually. If you want to live longer, go to the opera. Researchers in Britain have found that people who reported going to a museum or concert even once a year lived longer than those who didn't. So if you go to the opera once a year, you are going to live longer, right? No. What that says, what kind of people go to the opera? Probably Richie Riches. Probably people who have a lot of other things in their life going pretty dang well. Yeah, and I know you're looking, you're thinking, what do you need to charge a little bit better? Hey, whatever. Get off my back. So people were saying, look, want to live longer? Hey, if you go to the opera, you'll live longer. No. If you're rich, if you're the type of person who can afford going to the opera, if you're the type of educated person who probably even knows what the heck opera is, I've never been to an opera, then a whole bunch of other good things happen. So all we know is going to opera and living longer are correlated. Going to the opera does not cause you to live longer, contrary to what even the venerable New York Times says. Ugh. All right, whatever. All right, so we're going to talk about a relationship between two variables. If a change in one variable goes up, another variable changes as well. So the more, if you go to opera, you'll live longer. If you don't go to opera, you won't live as long as those people who do. That's correlation. But there are two different kinds of correlations, and we're going to talk about that in a minute as well. R, you will see R there. A correlation coefficient is R. So if you see R equals, you are going to see R equals something between -1 and +1. Here's what you need to understand about R. If the correlation is perfect. R equals +1. What that means is, as this number goes up exactly the same. Correlation coefficient of 1, you might want to write this down. Correlation coefficient of +1 says this one goes up, that one goes up, and they are going in perfect lockstep. Now, if it's -1, now I hate to do this to you, but I do the negative correlation dance. It means if one goes up, the other goes down. So a -1 correlation, if R equals -1, one goes up and the other goes down. So I have created the negative correlation dance. You may have seen it in Saturday Night Fever. One goes up, the other goes down. One goes up, the other goes down. You're welcome for that visual. Okay. So let's take a look at this correlation right here. Notice we've plotted some numbers. So person 1, they're 80 inches tall and their temperament is 75. So the temperament of 75, there's our 80 inches tall person, so we've plotted that point. So we've plotted all of these points right here, and it's not important for you to look at all those, but what we're starting to see is that there is sort of a general movement right here going from the bottom left to the top right. That suggests a positive correlation if it is going from the bottom left to the top right. That is not a +1 correlation, but it will be above 0. And I haven't talked about 0, so let me get back to that. If the R equals 0, if the correlation coefficient is 0, what that means is those numbers one number does not predict the other. They're just all over the place and there's no prediction. They are not related in any way. So if we had a correlation like that, a negative or a 0 correlation, we'd see dots here, we'd see dots all over this place. But notice this is empty and this is empty. So we're getting closer to a +1 correlation. I would guess that's probably a 0.5 correlation or something like that, but that is a positive correlation. That is what I was just talking about. This is a 0 correlation. You will see no relationship. There's every quadrant of this is filled up, so we would see no correlation. So that would be a correlation coefficient of close to 0.
I'm not sure I understand.
I don't know what that was. Now we will see a perfect positive correlation. So bottom left to top right, that is when this number goes up, that number goes up in a perfect lockstep. They are exactly related. Notice, so if this goes up 1, that goes up 1. That is a perfect +1 positive correlation. And this is a perfect correlation coefficient of -1. As this goes down, this one goes up. So as this goes down, this one goes up. That is a perfect negative correlation of -1. By the way, in real life, you will rarely see a perfect negative or positive correlation. It'll be pretty close to 0. I'm going to stop here because I've been doing too long, but okay, let's just review. So correlation means two numbers are related to each other. That if one changes, the other is going to change in a certain way on average. And the closer it gets to +1, the more we're saying that they're traveling like this. The correlation coefficient is exactly +1. If they're going like this, we're doing our negative correlation dance. One is going up and the other one's going down. If these two are totally unrelated, we're getting 0. And I will stress again, just because these two numbers are traveling perfectly does not mean that this causes this or this causes this. It might. We just don't know. There's only one way to figure that out, and that's to do an experiment. And I think Mr. Davis is going to talk about that in the next video. And it might be that other third thing that is making these two things travel together in a perfect +1 correlation coefficient. Okay? All right. 9 minutes. See you next time.